Today I'm going to show you an activity that will demonstrate and explain the process of finding an algebraic rule based on a certain pattern. And this activity is for third graders. So first let's look at our pattern. Here's our pattern and we're going to see what we first notice. And the first thing I notice is that it's a growing pattern. It's getting bigger and bigger. It's not a repeating pattern because it's repeating itself. And it's also, I also notice that it's adding a box each time, one box at a time. So now what we're going to do is construct a table describing numerically what's going on. So here's our table that I've already constructed. And on the right hand side you'll notice the number of boxes, also in parentheses I put B to represent the number of boxes. And we can see that it goes up 1, 2, 3, adding a box each time. And on the right-hand column is the number of sticks, which can also be represented as S, the number of sticks. And this goes, every one box there are 4 sticks added. For every 2 boxes there are 7 sticks added. And for every 3 boxes there are 10 sticks added. We can also see that for every box that's added, you're also adding 3 sticks. So 4 to 7 to 3, just adding 3. So now, if you're going to ask what the 10th diagram would be, you could do it just by following the pattern 3 plus 3 plus 3 until you get all the way down to 10, which is fine. But in order to know the 10th one, you need to know the 9th one so that you can add 3 to it. But to know the 9th diagram and how many sticks are in it, you need to know the 8th. And to know the 8th, we need to know the 7th and so forth. And this type of rule, when you need to know the one before it, is called recursion. And the limiting thing about recursion is that in order to know a particular term, you need to know at least the one before it. And that's very limiting because if you need to know all the ones before it, so we could ask ourselves, wouldn't it be great if we could just jump straight to the answer instead of having to do this process throughout the whole thing? And that's the benefit of what we're about to do. We are going to build an algebraic rule based on the patterns that we see, so that we don't need to know any other term. Once we've got the algebraic rule, we can just jump straight to that number without ever having to know any other terms before it. So let's figure out that rule. First thing I'm going to do is I'm going to write the numbers 4, 7, and 3 in a very different way. And I'm going to change 4, I'm going to write the number 4 as 3 plus 1. Now you ask me why I'm doing it as 3 plus 1. Well, let's look at the first diagram. We see that there is 1 that's always there, and then there's 3 around it. I'm going to show you craft sticks to show you how it's following the pattern using different colors. And then for the next one, we see that we have the same yellow. We also have the same 3 blues, but we're also adding 3 more. So we'll use red to show that we are adding 3 more. So now we could rewrite the number 7 as 3 plus 3 plus 1. Let's look at the next one. We have the same yellow one. We're same 3 blue that we added. We also have the same 3 red. But this time we're adding 3 more again. So we'll use green to represent this. Adding 3 more sticks for every square. So we can erase our 10 and write 3 plus 3 plus 3 plus 1. Now then, we know that this could also be said as one group of 3 plus 1. And this one could be two groups of 3 plus 1. And the last one could be 3 groups of 3 plus 1. And this is also, we know that this repeated addition is also called multiplication. So since we know one group of 3, two groups of 3, 3 groups of 3 is saying multiplication, instead we can just write, we can change all of these again and change it to 1 times 3 plus 1. Instead of two groups of 3 plus 1, we could say 2, since there's two groups, times 3 plus 1. And for the last one, we can change it to 3 groups of 3, which is 3 times 3 plus 1. So now you can see that there is a rule that is linking the pattern that is going on here. And if you notice that the number of groups of 3 that there are is the same number of boxes that there are. If there's 3 squares, then there's 3 groups of 3 plus 1. And if there's 2 squares, there's 2 groups of 3 plus 1. So now we can make our rule. And our rule is going to be the number of sticks is equal to the number of boxes times 3 plus 1. So I have actually written it down. Don't know if you can see it. Which is S represents the number of sticks equals 3 times the number of boxes plus 1. So now what we're going to do is let's test this rule to make sure it works with all the other terms. So what I'm going to do is erase what I have right here and construct a new one testing these. So we can do B, which is also number of boxes. And then right here, we're going to have our rule, which is S equals 3 times the number of boxes. We'll put this in parentheses because it's going to be changeable, plus 1. And for the last one, we are going to just do number of sticks. Barely fit. Also could be written as S. So we'll go down and do 1, 2, 3, 4. We'll go all the way to 5. Just draw our line. Okay. So now for our first one, we're going to put 3 and substitute the 1 for the number of boxes plus 1. So we know that 3 times 1 is 3 plus 1 is 4. So we know that that one works. For our next one, 3 times 2, because that's the number of boxes, plus 1. We know that 3 times 2 is 7 plus, or 6 plus 1 is 7. So we see that that one works. So now we have 3 times the number of boxes, which is 3, plus 1, which will give us 10, because 3 times 3 is 9, plus 1 is 10. So we see that that one works. So I'll show you 2 more just to show you that this pattern works for all of the terms. So 3 times 4, which is the number of boxes, plus 1 gives you 13. And finally, 3 times the number of boxes, which is 5, plus 1 gives us 6, And we see that this term works for all of them because we are still doing this continued pattern of adding 3. 3 plus 4 is 7, 7 plus 3 is 10, adding 3, 13, and 16. So now that we see that that this rule worked for all of them, we are going to use the algebraic rule to predict a future term in the pattern. So let's figure out what step 20 would be, or also diagram 20. So if we use our algebraic rule, which is, let me see it, S equals 3b plus 1. So we're going to need to know the 20th diagram. So in the 20th diagram, we know that there are going to be 20 boxes because it adds a box every time. We have 1, 2, 3. So by 20, we'll have 20 boxes. So for this, we can put 3, and we'll know that our number is going to be 20 because that's going to be the number of boxes, plus 1. And let's see what it would be. 3 times 20 gives us 60, plus 1 equals 61. So that we know in diagram 20, we will have 20 boxes and 61 sticks.